Hi, this is Jeff Eaton. Welcome to Applications of Deep Neural Networks with Washington University. In this video, we're going to look at how to train StyleGAN with your own images. So you've seen these great neural networks from NVIDIA that do faces, cats, dogs, churches, cars, other things. Now we're going to see how to take your own images and train them, even on Google Colab, if that's what you have access to. Let's train GANs. So here you'll see the 7.2 train GAN. This is in GitHub. I have a link in the description. Let's go ahead and open this in Colab so that we can actually do some stuff here. Now, Colab free, you're going to run into some challenges here because you're just not going to get the really fast GPUs. I'll show you some actual numbers here in a moment. You'll see I am using the most expensive $50 a month Colab Pro. That may or may not be worth it to you. Colab Pro gives you access to higher GPUs, but it's more convenience. So what I can do here is runtime, change runtime type, and I can do background execution. And believe me, you want to do background execution because you're training these GANs and it's going to go on for like a day. It's going to go on for days and days. So you can close your browser, exit the system, and get on with your life, basically, rather than having to keep a computer open and worrying about if Google is going to time you out or something like that. They're going to still time you out after 24 hours, but it'll shut down gracefully and you'll be fine there. I have a video specifically talking about if Google Colab Pro Plus is worth it. I'll link that in the video as well. You might be interested in seeing that to really compare these three levels of Google Colab. I am going to run this to connect the G drive because you absolutely are going to need G drive because that's where you're going to put your images that you're going to be training on. And yes, we're going to give it access. Let it do all of this stuff. All right, now we're connected. This is important. These are the three directories that you're going to be dealing with. These can be on your local drive. They can be in G drive. So images are where your raw images come from. Datasets are where you put the converted datasets in. And then the output, the experiments. Now notice I'm staying StyleGAN 2. And I need to update that. I decided not to go with StyleGAN 3 because it's too slow. Unless you have the latest ampere GPU, it's going to be slow. And we're dealing with V100, even if you've got the higher end Colab Pro, and I'll show you some times here. I'm going to probably do another video where I use my Ampere local GPU, my A6000, and do some training on StyleGAN 3. But that'll be a separate video. For the course where I'm assuming that you're using Colab Pro at the most, we're going to use StyleGAN 2. Now you can take the neural network that you've trained with StyleGAN 2 and you can use it in StyleGAN 3 just fine. It just won't be at the high quality level that StyleGAN 3 has, especially if you're doing the image transitions. Video and image transition is really where StyleGAN 3 shines. Here are some of the training times. This is where I was doing a 1024 by 1024. And you can see for Colab Pro on a V100, I was getting 566 ticks a second. That's pretty good. For a P100, which is what you also sometimes get in Colab Pro, and especially if you've been beating the heck out of it and they're starting to throttle you, it'll be about 18, 19 seconds per tick. That's not ideal. And Colab free, you're dealing with almost 2,200 seconds a tick, and that's going to take forever. And what I would consider, and this is where it's hard to justify if you want Colab Pro, because you're not going to always get that V100. In theory, if you get Colab Pro Plus, which is what I use, you get the V100 more often. But free, you're going to be stuck with T4s and K80s, which are going to go much, much slow. Now, here's what I'm talking about. If you use StyleGAN 3 on a V100, it's going to be 87 seconds a tick. And I haven't tried it on my A6000 yet. I would hope the A6000 could push that more into the 566 or maybe even 1,000 tick range. I don't know. I'm probably wishful thinking there. NVIDIA trains these on banks of 8 GPU. So you're in the big leagues when you're trying to train GANs, and it takes a lot of compute. So you're going to likely need to train for greater than 24 hours, and Colab will disconnect you. I don't care which of the 3 versions you have. After 24 hours, it's going to disconnect you. So you need to make sure that that snapshot point happens at least sometime within that 24 hours. Because if you snapshot, say, 14 hours in, and then you train for another 10 hours, you never get that second snapshot. That was all for naught, because you snapshotted at 14 and you're not going to snapshot again for another 14. That would be 28 hours. And unfortunately, Google just doesn't give you that much time. This is why I usually train these things myself when I'm doing high end and I'm going to be spending some money to get a high quality GAN. I usually use AWS. You can use Google as well. They're all the same. I just don't have time to learn everything about cloud ops, so I stick mostly to AWS. You're going to store all of your data in G Drive. And it's important that you store something as this goes. If you have Google Colab Pro, you have 24 hours to run a job, and then they will shut you down. Colab Free, you have 12 hours, and they will go in and cut you off if you're idle. There's a link that I have in here of how you can ping your computer at a regular interval using JavaScript so that you don't get knocked off of Google Colab Free. I haven't seen that running this script is necessary in Google Colab Pro. So this is how I set up my system to do this. Right off of my G Drive, I have a data directory. Inside of the data directory, I have this GAN folder. And these are the 3 that you'll want to create. There's dataset, that'll be empty initially for you. Experiments also will be empty initially. And images, this is where I put the images for whatever I'm trying to train the GAN on. If we look at circuit, that's one that I just collected. I have a nice utility for collecting these off of Flickr. I'll put a link to that in the description as well. I collected these from Flickr. These are just images of technology, of circuit boards, and I'm trying to create a GAN that can give me a computer-generated image that looks like a circuit board. You'll run a script that I give you in my notebook. You'll create data sets based on those images. It's very important. The images must be a power of 2, so 256 by 256, 1024 by 1024. If you want to totally go nuts, 4K by 4K, 8K by 8K. This gets slower and slower as big as you make these. I might do a video on generating 4K GANs. Let me know if you'd be interested in that. You'll run a converter and it will basically create, so you'll create something like circuit here, and it's going to generate this for you. This is the standard format that PyTorch likes to have these files in. And then experiments, as you run and train it, you'll get these generated. Like here you can see I was training on circuits. This is just when I first kicked it off. And then I let it go 24 hours and Colab kicks me off. So I start it again. I let it go 24 hours again. I get kicked off and it stops me. The fact that you will get interrupted out of nowhere is a very important consideration in this. You know that it's going to be 24 hours. So you need to balance your checkpointing. You'll see training steps as it goes through. Normally, by default, if you don't tell it anything else, it's going to checkpoint, save a copy of your network, and evaluate it every 50 steps. 50 steps is way too big if you're doing 1024 by 1024, because if you get interrupted in the middle of one of these checkpoints, so say you checkpointed last at 50 and now you're on step 99 and you get shut down, you've lost those last 49 steps. You may say, oh, I'll just checkpoint at every single step. Well, checkpointing sometimes takes up to an hour, so you don't want to make too much use of it. The strategy that I use is I do calculations. I let the first few of these go through and realize I'm going to get interrupted at inoptimal times. Then I try to put a checkpoint real close to the end. I will calculate how many steps I can get for, say, 23, 22 hours, something like that. And then I checkpoint right at the end, make sure there's enough, and figure that last hour is kind of slush and it's going to get interrupted. So continuing on with my notebook, go ahead and open this in Colab. And now that we're there, those are those 3 directories I told you to set up. Let's see what sort of GPU we have. You run this command right here. If this tells you don't have a GPU, then you need to change the runtime type up here. Just go to runtime. I have a P100, which is unfortunate. This is Google throttling me. I've been hitting this thing hard. After you run this about 3 days in a row on a V100, which is the faster one, they'll punish you with a P100. And it's interesting. I'm curious how long I'll be in the penalty box before they give me a V100 again. Just to give you an idea, if you're running Colab Pro and you've been fortunate enough to get a V100, you're going to get about 566 seconds per tick on 1024 by 1024. So you can calculate out about how long that's going to take you. Trust me, if you're doing 1024 by 1024, you're going to be doing this for days, maybe weeks, to get really, really good performance out of it. Unfortunately, they only give you the V100 for so long, and then they're going to take you down to this P100. These are both on Colab Pro. So even though I'm paying them $10 a month, they are not going to just give me that V100 infinitely. The more you use it, the more they sort of downgrade you. Going to a P100 hurts bad. You'll notice here my training time, exact same setup, has gone to nearly 1900 seconds per tick, taking just about 3 times as long to run it. Even worse, when you go to Colab Free, it's even slower on this T4. What I tend to think about is if you compare Colab Pro to Colab Free, is it really worth it for Colab Pro? I'm still going to say yes, although you have to really budget this into what you're thinking about for Colab Pro. Basically, that $10 a month is going to get you about 3 days of continuous use V100. As of today, none of this is official from Google. This is just my own observations before they start throttling you down to a P100. Now, I'm not entirely sure if you keep using the P100 like crazy, are they going to throttle you down to a T4, even in Colab? Even if they take the fancy GPU away from you in Colab Pro, you still got 2 primary advantages. One is you're able to launch a terminal. So see here, I'm basically in a terminal. You can actually run all these commands out of the terminal. So if you want to do NVIDIA SMI and just run it from the terminal, you can run it here. This is a matter of preference. You may prefer to invoke these commands that I give you directly in the terminal. The other advantage of Colab Pro is it's going to run for straight 24 hours as opposed to 12. And if you're trying to kind of play Tetris and get your training runs into there, dealing with a full 24 hours is much easier to deal with than 12. Otherwise, you're going to have to be restarting this thing manually twice a day. There are tools that will let you run a script on your local computer and restart this automatically. Those are outside of the Google terms of service that they publish. So you're operating illegally by what you've agreed to with Google. So I don't really cover those. As I understand it, everything I'm telling you in this video is within the bounds of what Google wants you to do. Now, if you want to live outside the bounds, I will tell you those programs do change rapidly because I think they're playing kind of cat and mouse with Google. If you're running Google Colab Free, if you're not interacting with this thing on a continuous basis, they're going to disconnect you after about 30 minutes, maybe 2 hours. I don't know exactly what that is, but I gave you a link to here so you can use a JavaScript program to prevent you from disconnecting. Now, to set up your new environment, we're going to run this, and this is going to connect me to my G drive. It just takes you through a series of screens. I clipped that. Don't want you necessarily seeing all my Google IDs and various things. It gives you an authorization code. That's completely safe for you to see. Now we're connected at Content Drive, so my running instance here can see my G drive. You have to also run this. Now you will have StyleGAN 2 ADA PyTorch installed. You'll want to find your files, get the correct directory for them. Next, you need to convert your images, and you only need to do this once. Once you've created that directory there on your G drive, don't just keep rerunning this because it does take a while. When you run this, it's going to take and run the dataset tool. That's the source, and that's the output. This will just run. It's very picky. If some of your images are different color depths, are different dimensions, then it's going to bomb out. And if it bombs out, you need to uncomment this line and run it to delete your data set. You can also, if you want to, just use the G drive interface and delete it as well. Same thing. The directory has to exist, but it has to be empty. If you are having trouble with your images being different color depths, different dimensions, unfortunately, the dataset utility that NVIDIA gives you does not give you much information. It just bombs out and says one of your images doesn't align. This will scan all of your images and tell you which ones are non-compliant. I use this to help me do that. Then you delete them, fix them, whatever, rerun. This is your initial training. And I say initial because this is going to get interrupted. Unless you're doing a really trivially simple GAN, you're not going to get this to run in under 12 or 24 hours. This is the directory that the experiments, that the output is going to go to. Each time you run this, it's going to create a new folder in here. We'll look at these in a moment. And then this is the data directory that it's going to train from. This is your snapshot size. If you're using one of the more simplistic GPUs, earlier GPUs like a P100 or T4, you want to have a snap size probably of about 10, unfortunately. 25 is what I usually use on the V100. And notice what it's saying down here. It says, warning, you are connected to your GPU runtime. You're being wasteful, basically. But I'm going to be using the GPU in a moment. Google's getting impatient with me. So let's go ahead and kick off the training. You click this and run. The other thing that you could do is copy that CMD and run it on the terminal if you have Google Colab Pro and you'd rather be running on the terminal. This takes a little bit to start up. The first thing it does is just throws all this JSON at you. There's a lot of startup sort of preamble that this thing goes through. I'll show you what it looks like when it's actually running in a moment. I don't want to completely wait for this thing to start up. This could be 10 minutes easily. Now, when you want to resume training, it's a little more complicated. You still give it the experiments directory, that's the output, but you're going to give it a network name. This is the network that you were last training on, that it last saved, that you're trying to resume. So if you look at what I'm doing here, this is 008, blah, 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 blah. If I go into G Drive and I go into the experiments, there is that one. So I continued this one onto this one. So if you look at this one, this is what the guts of a training run really looks like. This one did not get very far. You can see fakes 0-100. This was training on one of those P100, so it just didn't go as good. It did train for a while, though. If you look at the log, you can see what you would basically be seeing on the output here. This is all the preamble. This is when you really get into the meat of things. The first thing it does is evaluates how good your network is. What is the FID? FIDs are how you score a GAN. 43 is not good, but it's moving in the right direction. This will be well above 100 when you're first starting. These are all the ticks, and you can see how long each tick is taking and the seconds per tick. You want to be very mindful of that because you'll want to optimize this and figure out how many ticks you can squeeze into 24 hours and still have a time to do one of these final checkpoints. You can see the total time on this is much longer, 22.94. So basically subtract that from your 24 or your 12 and then divide up and see how many ticks you can run and do just one run and save it at the end. These checkpoints are simply for recovery. They do not do anything to enhance the quality of your train. The other thing that is very important are these pickle files. You'll always want to resume the last one, unless perhaps you saw your FID drop drastically due to overfitting, but you'll probably grab the last one, and that's the value that you're putting into it to continue from. You can also look at the fakes, the PNG file. This is interesting to look at. It takes a moment for this to come up because it's a fairly large image file. But you can see here, these are the fake circuit boards that it's learning to build, and it's making some progress. This was trained entirely on Colab Pro, and that's it. You just keep rinse, repeat this over and over and over. At the end, you're going to download your pickle file. These are pretty big, 352 megabytes. And you can use that as your starting point to generate GANs from it. I've got other videos where I show you how to generate GANs. You can also just use your fakes file here. That's some generations. But you'll probably want to generate your own so you can generate a large number. Have a look at my GAN generation using Colab. I've got a video linked to it at the bottom. Thank you for watching this video, and if you want to stay up to date with this course as well as other projects that I work on, please subscribe to my YouTube channel and give this video a like if it was useful to you. Thank you for watching.